For today's E-Club program, our special guest has been a scientist at the Jet Propulsion Laboratory, the famous JPL in Pasadena, for more than 20 years. He is award-winning on various levels from JPL, NASA, and other places. He has represented NASA and JPL at conferences around the United States and the entire world, including in different languages. He hasn't yet represented us on the International Space Station, but we're working on that somehow. He is an oceanographer and a climate scientist, and he's going to tell us about something that is bearing down on us at what they say is an alarming rate. El Niño is on its way, and he's going to teach us what that means, where it all comes from, and we'll talk a little bit about his expertise, oceanography and climate scientist. So please welcome our special guest today, a member of our club, Dr. Jorge Vazquez.
Thank you,
So Jorge, before we start the talk, we'll pretend we're on the Ellen show and show our favorite funny cat pictures back here on the screen. So let's go from the general to the specific. In general, what's El Niño?
El Niño, the word itself was actually coined by Peruvian fishermen in the 1800s. And what happens is the currents in the Pacific Ocean bring warm waters to the South American coast every year. So the word El Niño was associated with the miracle of Christmas. That's the original, how the original word terminology came to be. However, in the 1970s, and he was actually the professor, the mentor of Bill Patzert, Klaus Wittke, who is literally the father of the modern El Niño.
Bill was one of the experts who we'd hoped to have here today, but was unavailable.
But he's actually, you know, and I apologize, he actually really would have loved to have been here. Unfortunately, he's very high in demand right now for obvious reasons. Klaus Wittke discovered that not only do the waters warm every December, every 5 to 10 years, they get very, very warm. And they cause climatic changes over the entire world. So El Niño has gone from this warming that occurs every year that was coined by the Peruvian fishermen to now a scientific and climatic event that literally has consequences over the entire world.
Now, what does the warming of the water, well, let me back a step. What causes the ocean's temperature to change like this?
In general, the trade winds in the Pacific Ocean blow from east to west. And remember, those trade winds usually, you know, blow around the equatorial Pacific, between about 10 degrees north latitude and the equator, and a little bit south of the equator also. Every few years, those winds actually die down or actually reverse. Now, those winds in the Pacific push all of this warm water to the western Pacific. The western Pacific usually is one of the warmest bodies of water in the equatorial Pacific in the world. When those trade winds actually reverse or die, all of that warm water can come back to the eastern Pacific. And that's what the modern, you know, word El Niño means. That the trade winds that blow all of this, you know, that blow east to west in general actually die down, and sometimes in particularly strong El Niños they reverse. They then blow from west to east. And all of this warm water that's been piled up in the western Pacific comes back to the eastern Pacific. So all of this warm water moving on the face of our planet has incredibly large consequences for climate all over the world. Because basically, remember, you know, the atmosphere follows, in a sense, how it reacts and causes all of the water vapor and all of the clouds to form. It follows the warm water in the ocean. So when warm water moves, climate moves with it also.
So it's the oceans that are controlling what's happening above in the atmosphere more than pretty much any other factor?
It's almost a chicken and egg argument, you know, and this is where it's a particularly difficult problem of prediction, because in fact it's a feedback mechanism. You know, the oceans feed, in fact, warm water to the atmosphere, which causes clouds to form. The atmosphere is then, you know, then causes rain, and in fact then also causes the winds to change, then also causes the currents in the ocean to change. So it's a feedback between the oceans and the atmosphere. And you can imagine how hard this is to actually be able to predict. But the good part of it is larger and larger computers that we have today, and we all hear about cloud computing. Well, we're running very large models now on clouds and on these supercomputers, and they're allowing us to really understand much more about El Nino.
What's the temperature difference? When you're saying the water is warmer, and what I'm trying to get my head around is, on that grand a scale, how much warmer is the water? I mean, for example, if I were to go from the equator up or down towards a pole, are there bands that are different temperatures, and how wide a range is that?
He's smart, Yes, great question.
He lies a lot. Go ahead.
No, in fact, Mel, that actually hits the nail on the head. In one specific part in the Pacific Ocean, if you just measure it at one particular part in the equatorial Pacific, waters in general are about 3 degrees warmer during an El Nino event than they usually are. Now, 3 degrees, again, doesn't sound like a lot. But it's not that it's a one specific ocean. It's this warm water extends now clear across the Pacific Ocean, which is about 10,000 kilometers. So think of not in terms of just temporally at one point. Think of what happens spatially and geographically. It's a huge disturbance. So now, basically, over the entire Pacific Ocean, in the equatorial Pacific, I should say, you have waters that's sometimes about 3 degrees warmer than they usually are. So it's a huge, huge event. And that's why, in a sense, some of the impacts, I'll give you some example. When you have the shift in warm water from the western Pacific to the eastern Pacific, what do you think happens in Australia? They have drought conditions, severe drought.
Because the ocean's getting cooler
where
on
they
their
are.
side, and it's
Exactly.
Now, how does that cause the drought? Is it because there's less evaporation?
Exactly. Exactly. No.
Okay.
Where you have warm water, you have more evaporation. Where you have more evaporation, you have more clouds. Where you have more clouds, you have more rain. So when warm water moves, so does the areas where you have more rain moves. So when the warm water moves from the western Pacific to the eastern Pacific, Australia is not anymore going to have the benefit of these nice, rainy seasons, and that's why they have severe drought conditions. Fortunately for us, or in South America, too, it ends up bringing more, usually wet climate to both California and the East Coast, the West Coast of North America, as well as the West Coast of South America, too.
I don't want to get too far away from the focus on El Nino, but the oceans are somewhat of a big deal, increasingly so, because we've all heard a lot of talk lately about rising sea levels, which is a different idea from just the water. There's something going on in the North Atlantic, as I recall you're mentioning at some point, that causes similar, again, global effects. I think that's the part that Jorge has taught me just chatting with him over the course of time. You think you are here, but it's still one planet, and it's one atmosphere, and it's one water system that happens to be divided into oceans, but all those oceans are run into each other somewhere. So what's happening in the North Atlantic that is having these other effects?
Well, and that's a great question again. What can cause sea level to rise? One of the things, if you just heat water, when you heat water, it expands. And if you heat it above the boiling point, it evaporates. So one of the things that causes sea level to rise is simply, as we all know, it's a huge concern, rising temperatures. What's the other thing that can cause sea level to rise? If ice melts. Okay? Now, one of the reasons that scientists are so focused on the Greenland ice sheet, for example, and this is going back to Archimedes' principle, if you already have ice in a glass of water and it melts, it's not going to affect very much how, the level of water in that glass. However, if you put in more ice and it melts, it absolutely will cause the level of water in that glass to go up and maybe even overflow. Same thing in the oceans. Greenland ice sheet, ice over land. If it melts, you know, there's a very huge concern in terms of how much the sea level will rise over that, because of that. However, if sea ice melts, it's not going to have a huge effect on sea level rise. Now, scientists have actually estimated and quantified this very accurately now. They know about 1/3 of sea level rise is due to the melting of the glaciers. And significant. So that's why when you hear on the news and you hear the focus of things like land ice and on the on the Antarctic ice sheet or the Greenland ice sheet melting, that is why the focus is there, because land ice melting can cause sea level rise.
So the ice shelf in Antarctica, is that land ice or sea ice? I get that now. I'm for the first time today. Yes. I'm confused now.
Some of it is land ice and some of it is sea ice. It's both.
It's both.
Exactly.
So the sea ice won't cause a significant rise in the global
Right.
level, but any land ice.
Absolutely.
What you're saying is that if I move the ice from a glass of ice over here and pour it into the water glass,
yes,
that water glass is going to expand. The ice that's already in there isn't going to hurt as much.
Yeah, if it melts, if the ice that's already in that glass, if it melts, that glass is, you know, the water level is not going to go up. However, if Assistant Governor Akiko pours her
Yeah.
ice into, you know, into Sarah's glass, then it will absolutely cause the level,
that level to go up.
Yeah.
Right. Okay, so coming back over to the Pacific with El Nino, what is it seasonal in terms of where Earth is in relation to the angle and the sun? I mean, I think everybody here is aware that Earth isn't squared up with the equator facing the sun. We're at an angle, which is what causes seasons. I think the only seasons are baseball, hockey, and different problem. So what would then cause the El Nino condition of the warming of the water around December? What would, if anything, cause it to come back down?
Well, the main trigger are the winds, are the trade winds.
Okay.
You know, please remember, El Nino has nothing to do with solar cycles or the tilting. There are certain things that have to do with changes in the solar cycle and the tilting of the Earth's axis. Remember, the Earth wobbles around its axis. It is like a top. So that does have an effect, they know, over very, very long periods of time on the climate of our own Earth. Okay, but that's a different time scale altogether at El Nino. El Nino is an atmospheric oceanographic phenomenon which is basically triggered by changes in wind in the equatorial Pacific Ocean. However, again, it has huge impacts over the entire world, but it is not the relationship with the solar cycles or the Earth wobbling around its own axis. So the fact, and remember, you know, the fact that the Earth's axis is tilted causes our seasons.
What makes this year's? I mean, everyone's talking about the what was it, 97 or so, when El Nino was particularly severe around here in terms of causing a lot of rain. What makes this what makes the coming cycle apparently so as intense, more intense than previous years? Going back to that one, what is rising, making this one worse, more intense?
There were 3 El Ninos that were in recorded history back to the 1970s. I said there were huge events. The 82-83 event was huge. It cost billions of dollars in damage over the entire globe. The 97-98 event was huge. I remember because I was skiing in Mammoth in July, and I don't know why I have that T-shirt. I skied in Mammoth in July, you know. I still have it. So I remember that year very, very well. We were up there skiing in July in Mammoth. Great snowpack. The other one, 1997, 98, 80, and 80, and we also had a small one in 92 and 93. When you look at 2 things, you know, scientists look at to be able to predict El Nino. One, sea surface temperature. The temperature at the very surface of the ocean is warmer than usual in the equatorial Pacific. The other thing they look at is sea level. Is sea level rising in the equatorial Pacific? Why those 2? If sea level rises, it's just as I mentioned, there's a couple ways to change the level of the ocean. One of them is you add heat to it, and the other one is if ice melts. Well, if sea level rises in the Pacific Ocean, we know that the amount of heat is also changing. It's also going from one place to another. If the temperature at the very surface of the ocean changes, we know there are things happening between the atmosphere and the ocean. Now, one of the things that this year, when we look at how the temperature is considerably warmer in the equatorial Pacific this year, the sea surface temperature as well as sea level, and we look at those maps, we say, wow, not only are they similar to the 82 and 83 event and 90, 97, 98 event, their whole extent seems to be even larger. So everything seems to be in place. Now, for a large event this year, the question is, will it have staying power? And this is one of the things that, yes, we do rely on models. Remember, models are a tool. The other thing to remember is that in California, because this is what we're all interested in, is are we going to get more rain? Will Mammoth have a good snowpack? Not only for skiing, but that's where we get our water from. Most of our water in Southern California, so it's critical. I joke about that, but it is critical. When you look at the relationship between an El Nino event and the snowpack in California, you'll notice that there is a very strong relationship between the strength of El Nino and whether the eastern Sierras will get a lot of snow. So there is a relationship there. However, the other thing to remember is it's not a 100% correlation. That means that it's never 100% certain. All we can say is, yes, the probability that we will get more rain, we will get a better snowpack, is much higher during an El Nino event. So yes, everything is in place. That it seems to indicate that based on comparisons and models, you look at the 82, 83 event, the 97, 98 event, and now the, what's happening currently in the Pacific Ocean, it looks like we are headed for a major event, this year.
Something that one of your areas of expertise is the ocean's salinity. How much salt there is, to the point where if someone at that end of the table were to drop a pinch of salt into your glass of water, he could probably tell you from here to there what the percentages were.
Yeah, it's actually amazing. One of the areas that we're very interested in is, obviously because of what we've seen in California, is the Earth's water cycle. If our planet is warming up, what kind of an impact is that going to have on the water cycle? So we now have satellites that can actually measure how is this related to salinity? Well, if water evaporates, what do you expect? Will the salinity in the ocean go up and down, or up or down?
Down. I mean, sorry, I thought up.
It's going to go up.
Because the water is going into the atmosphere and the salt is staying behind.
Good school. Good science class. Excellent. So he's absolutely right. You're removing water from the system, the salt stays behind. So salt's going to go up. So salinity is a perfect, for lack of a better word, is a perfect tracer, in a sense, for the Earth's water cycle over the oceans and how it's changing. One of the areas I'm looking at is now, for example, looking how flooding events, we just published a paper a couple years ago on how a major flooding event along the Mississippi River had a major impact in freshening in the Gulf of Mexico. Why does anybody even, again, it's a perfectly reasonable question. Oh, yeah, but why does anybody care? Well, because general freshening events can also affect temperature and can also affect the amount, remember, the biology follows also salinity. Fish have a tendency to follow temperature and ocean salinity. So all of these things come together, but the basic area of focus, again, is trying to understand how the Earth's water cycle will change with our planet warming up.
So the freshening is that fresh water coming from the river flowed into the saltwater Gulf of Mexico. So now you're adding water. Again, the salt doesn't change. It's the amount of water around the salt, and so it's the percentages that are changing.
Exactly, it's the percentages that are changing. So it's measured then as a freshening.
Right. So the salinity content, content of the Gulf, was reduced. The percentages.
Exactly.
So that affects the marine life that's used to living in one environment is now suddenly living in a different environment.
Exactly. Exactly. So all of this, and again, for us here in California, one of the areas that I'm focused on is how does El Nino affect the fisheries off of California? In a warming environment, how is it going to affect? And by the way, we already saw this year, because one of the large differences between this El Nino and what we saw in 82 and 83 and 97 and 98 was that, I don't know if you've heard the warm blobs that we have off of our own Pacific coast right here. And they have caused large changes in the kind of fisheries that we're seeing. So right now, we're trying to understand, we have a little bit of an idea about what causes these warm blobs, but the question is, since it's different from what we've seen in past El Ninos, how is this all going to come together?
What is the warm blob? Is it an area of particularly warm water?
Warmer, yeah.
Just but like a blob
Exactly.
instead of interesting, like a pocket.
Exactly, and we haven't seen, right now you have this warm blob that's over Alaska, and a warm blob that's over the southern part that extends into Baja, California
Is that
also.
oceanic or
It's
or
an atmosphere, they think, again,
Okay.
it's a connection between the atmosphere and the oceans. And they think that these warm blobs are basically because of maybe the high pressure systems. Remember, high pressure systems usually bring warm weather. Low pressure systems are usually the ones that bring cooler weather. Well, this past year, and by the way, very timely, thank you for allowing me to give this talk today, because NASA and NOAA just came out yesterday saying July was the warmest month ever.
National Oceanic and Atmospheric Administration,
Globally,
NOAA,
Yeah.
globally.
So, again, how all of this comes together, El Nino, these incredibly warm temperatures that we're seeing off the Pacific Ocean, and climate, the global warming, how this all comes together in terms of predicting our own weather in Southern California, we have to wait and see. But everything is in place that we should have hopefully, more rain this year.
More rain to help us,
Exactly.
without being too much to flood us. But then again, it becomes cyclical again, so
Yes.
that it should. What is it that causes this complete change in the direction of the winds over the Pacific?
Well, and that's a great question. That's not very well understood, and that's one of the triggering mechanisms. Again, is it the oceans that's affecting the atmosphere, or is it the atmosphere that's affecting the oceans? We do know to a certain extent, obviously, again, with warm water, we know that it affects the circulation in the atmosphere and affects the winds. But again, the triggering mechanism, right now, most models, just so you know, can predict maybe 6 months to a year, maybe 6 months, I would say, an El Nino event. But we're not very good at predicting the intensity of the event. Think of it in terms of hurricane prediction. Okay? Hurricane prediction has gotten, because I remember as a kid when Hurricane Camille hit, the Mississippi coast. People think of, which was, there's only 3 Class 5 hurricanes they think have hit the U.S. mainland: Camille, Andrew, and the one in early 1900s. Okay, Camille caused most of its damage when it came inland, and part of the problem was also that at that time, how they tell you, the path of that hurricane can come in through this entire, from, Florida to Texas. Well, that's might not be very comforting. You have to evacuate everyone then.
Yeah.
Now, because of the computer models, if you notice, that shrunk considerably. However, just like with El Nino, one of the problems is predicting the intensity of the hurricane is still not done very well. There have been improvements, but we still have a long way to go.
As an aside, in at least in my opinion, and I'm going to dare Jorge to disagree with me on this, a lot of people say, what's the value of the space program? Why do we have to put astronauts on a space station? What good is that for humans? And once you get past the medical advances of having humans in microgravity to test, all of the space program advances of trying to put someone on the moon led to all of the satellite advances that lead to all of the data that lets us save lives by doing what we can to improve these predictions. You had a major part in the Aquarius mission, studying the ocean stuff right now, leading to some of this stuff.
Yeah, and I think that, the thing to remember is always that, I think one of the things that we should be focusing on in terms of understanding things like Mars and Venus. For example, Venus has a very thick atmosphere of what?
Few things, including some
Carbon dioxide.
Carbon dioxide, yeah.
So why are we even, concerned about carbon dioxide here on our own planet? It's the major greenhouse gas that's been basically put into our own planet. Now, let's be very, very clear, and I think I said this, the last, CO2 naturally occurs in our atmosphere.
Yeah.
The problem is, since the Industrial Revolution, we've seen a lot more of it than we usually have. So Venus is a classic example of where you have so much CO2 in the atmosphere, it has a greenhouse effect gone completely crazy. Its atmosphere is so thick with carbon dioxide, the only way to actually see the surface of Venus is with a radar, because it can actually penetrate. Its atmosphere is so thick. Now the other thing, obviously, there's an interest in Mars. Why is there such an interest in Mars? Also, besides the finding little green men thing, is because there's every indication that at some point there was water on Mars. Every indication that at some point there was water on Mars. The question then has to be asked, did Mars suffer some kind of cataclysmic climatic event? There's a lot of things. We really don't know. We really don't know.
Learn from it.
Yeah, exactly.
We have a few minutes to take questions from people other than me. I saw Joanne's hand just ahead of Linda's and then Todd. So, Joanne?
One thing that I'm kind of concerned about is that I've been hearing a lot about marine mammal coming up, losing their lives and changing. And does this change in the water and the El Niño affect the marine life? Is that what may be killing them?
That's a great question. The answer is yes, absolutely yes. For example, I've worked with, colleagues in Peru, and El Niño there can have catastrophic effects. Peru has one of the largest fisheries in the world because of why? You have cold water from beneath the ocean that comes to the surface. In oceanographic terms, we call that upwelling. And why? What does cold water have to do anything? Well, cold water usually has more oxygen. It's more oxygen is soluble in cold water. More oxygen means, in general, more life. So Peru has a system where cold water comes from very deep to the ocean to the surface, and it has one of the most productive fisheries in the world. What happens during El Nino? This warm water comes back from the Western Pacific to Peru. It shuts down that cold water. So the economic consequences can be huge. Now, one of the areas we're studying also is something called, in terms of global warming, and, the effects. Remember, El Nino is on the order of 5 to 10 years. Climate is on the order of decades and into 100 years. But one of the things we're looking at, if you have more, carbon dioxide gets in the ocean in two ways. We all know about photosynthesis, and we all know that there are little things in the ocean called plankton. Well, plankton take in take in carbon dioxide. So that's one way that the oceans take up carbon dioxide. The other way is it actually just dissolves in the ocean. The issue is when carbon dioxide dissolves in the ocean, it forms carbonic acid. And that's why you probably have heard of this issue of ocean acidification. Well, again, animal life, if you start changing the pH of the ocean to make it more acidic, it absolutely will have an effect on the biology. So that's also one of the areas that people are focused on. I'm trying to actually look to see if by the way, off of California, we also have cold water that comes from beneath the ocean to the surface, which is also why we have, not as productive as Peru, but we also have an incredibly important fisheries industry. Again, you know, how will that all change if the ocean temperatures are rising? Huge area of research, which is actually one of my, you know, focus points right now. How will that change if the warm water, you know, because we also know, as an example, we know with El Nino, and we've already seen it with these warm temperatures off of California, absolutely, you know, fisheries are changing. They already have impacts on the salmon industry. So again, this is stuff that's happening right now.
Linda?
Okay, my question is, you talked about the modeling that you have on the computers, the big computers and the cloud computers. What, if anything, do the models predict in terms of timing of this particular El Nino?
About this El
This
Nino?
one, yeah.
Yeah. NOAA has basically, based on these model predictions, has predicted a major event for this year. Again, one of the problems is that, you know, we can say there's a major El Nino event. But when you look, for example, if you look at a map of California and how it's related to El Nino events, it's different depending on where you are in California. The good news for us is that the highest relationship between El Nino and rainfall in California occurs where? The Eastern Sierras. Great news for us. What's the big unknown? You know, we want a snowpack. That's what we want. We don't want a rainfall in Mammoth that's going to just sink into the soil. That's not going to do us much good. So the big factor in all of this is, again, temperature. Will the temperature be cold enough for, you know, the right snowpack in the Eastern Sierras to form?
Now, you said that the El Nino can be predicted 6 months out, right?
In general,
In general.
yes,
So
yes.
are you saying, so are the models showing that it's coming in October, November, December? We don't know.
Well, remember, I mean, and that's a great question. You know, if we compare, and this is where there's a difference this year, the 82-83 event peaked in December. And again, how do you define peaked? Basically, when the sea surface temperature anomalies were the highest. Okay?
You mean when it was the most warmer than
when
it
it's the
usually
warmest.
is?
Exactly.
Not the warmest, but the most warmer than normal.
The normal, exactly.
For the
Anomaly,
period, okay.
exactly. Anomaly
Okay.
is the difference between what's happening exactly at this time of year and the normal conditions. And the 97-98 event again peaked around, you know, around December. This event, we've been seeing it already since you know, May and June.
Already building. Todd, we have time for one last question.
It's a real quick one to take in a different direction and avoid the temptations to pull into a debate on climate change. I know one of the things that I remember hearing a lot about when there was the big El Nino in the late 90s was all the increase in malaria and encephalitis and all these things that start spreading, and in developed areas too.
Oh, absolutely.
Is there any expectation? I don't know if this touches on your, but you know, what expectations should we have as these heavy rains come, in particular, like West Nile virus? I mean, are these things we should be looking at outbreaks?
You know, I think, you know, I'm not a biologist. You know, the only thing I'll say, Todd, is that relationship definitely exists. And why? Because if you have more rain,
You have more bugs.
you're going to have more stagnant water. And certainly, you know, that's an issue. You know, how that's handled, I don't know. I mean, one of my concerns, and I'll have to be perfectly honest with you, is with the number of fires that we've had and the loss of topsoil. If we have major rainfall this year, all I can say is I would love to live in Malibu Canyon, but I'm glad.
Right now that you don't.
I'm glad I don't have enough money to have a house there. Because yeah, I mean, this is a serious situation, very, very serious situation. You know, we've seen already the fires that we're having this year.
All of the events, from fires to floods to hurricanes, seem to be more intense over the past several years.
Yeah.
Just everything is more intense of whatever it was. Okay, look, one more real quick one with Avi,
Yeah,
we're going to have to
I
wrap it.
hope this is a quick question. It's about upwelling. I believe generally colder fluids are lower. So what's causing upwelling? Is it the convection currents?
That's a great question, and let me I'll give you the science,
Yes,
scientific response. Usually when you have winds, for example, this happens off of both Peru and California. the winds blow along the shore, north-south, and they usually blow to the equators, toward the equator. Very typical condition for California and Peru. When that happens, when the winds are blowing toward the equator along the shore, it pushes water offshore. So if the surface is being pushed offshore, it has to be pulling water from somewhere else. And where does it pull the water from? Depth. So that cold water from depth then comes to the surface because the surface water is being pulled upshore. So it comes like this.
Thank you.
And that's all because of basically these winds that off of both California and Peru usually blow toward the equator along the shore. So that's a great question. Great question.
A lot to consider, a lot to learn. Get your umbrellas ready, but mostly hope that he's skiing again in July, because apparently that would be the best thing for us in California. Ladies and gentlemen, thank you
so
for
much.
enjoying our program.
Thank you so much.
And we'll have you back for an update and see if you were right.
Yeah, exactly.
Perfect.
Thank you.